Okay, so in this case, I'm also enforcing the equation for Vx equal to, actually, I don't have to enforce it for any v that satisfies the constraint. I only have to enforce it for Vx equal to phi0 of x, or and Vx equal to phi1 of x, and x equal to phi2 of x, and v equal to phi3 of x, right? Because look at this weak form again. So look at this weak form again. You know, if the weak form holds true for phi0, for v equal to phi0 and v equal to phi1, for example, it also holds for phi0 plus phi1, right? I mean, just to write down the two equations. If you replace v with phi0, replace v with phi1, what you get is I'm just going to do it here. You're going to get the integration of phi0 dx du dx is equal to phi0 times f dx. You're also going to satisfy the equation for d phi1 dx du dx is equal to equation from 0 to 1 phi1 f dx, right? So if my solution satisfies both these equations, then if I add these two equations together, what do we get? We get basically the same equation, except for the phi0 is going to be replaced by phi1 plus phi2, right? Right? We basically satisfy the equation for v equal to phi1 plus phi2. Or if I perform any other linear combination of these two equations, I actually obtain the weak form for v equal to any linear combination of phi1 and phi2. Now, if I enforce this equation for v equal to phi0, phi1, phi2, and phi3, and then I perform arbitrary linear combination of these four equations, each one a weak form, right? Then I'm pretty much enforcing the weak form for any v that can be represented as a linear combination of v0, v1, v2, v3, which is basically saying that I'm enforcing the weak form for any v that satisfies the constraints of piecewise linearity and continuity, right? Okay, any questions for why I only need to enforce a discrete set of v's to get the enforcement of the weak form for basically an infinite set of functions, test functions v? Yes? No? Okay, this is really the power of linear algebra in its most general sense, right? So basically, the set of constraints we are enforcing. So why are we setting v equal to phi? Okay, we're setting v equal to not just the one phi, but all of these phis, so that we are enforcing the weak form for all possible v's that can be represented as a linear combination of these phis, right? I mean, here we have performed an analysis that says that any piecewise linear and continuous function can be represented as a linear combination of these four phis. And that means if we want to enforce the weak form for any v that satisfies the constraint of piecewise linearity and continuity, then we are basically required to enforce the weak form for v equal to any linear combination of these four phis. And because of linearity, if we enforce the weak form for the discrete set of phis, then we are basically enforcing already the weak form for any linear combination of these phis.